In this problem, we need to determine the equation of a parabola such that the focus is at -6, -6 and the vertex is at -2, 2. Let us begin. So first, what we'll do, we'll consider a straight line on which the focus as well as the vertex lie. So here, let's say we have a straight line. We consider a point which is going to be the vertex of the parabola. It has the coordinates -2, 2. And then we're going to consider another point on that same line which is going to represent the focus of the parabola. So it's given here at -6, -6. Now, by definition, when the vertex and the focus lie on that line, the name of the line is referred to as the axis of the parabola or the axis of symmetry line. Now, by definition, we know that if we consider a third point on the same line, let's call this point as point A, then this point is going to be it is placed in such a position that the distance of the vertex from this particular point A is exactly equals to the distance of the vertex from the focus. Now, this is a very special point because this is the point through which the directrix of the parabola is going to pass through. And the reason we want to find out the directrix of the parabola, because with the help of the directrix and the coordinates of the focus, we will be able to obtain the equation of the parabola. Okay, so let us begin. So this is what we want to do. So we have the axis of symmetry line or the axis of the parabola where the coordinates of the vertex and focus are given to us. Using these two information, let us try to find out the coordinates of point A. To begin with, what we'll do, first let's try to find out the slope of the axis of symmetry line. So here we're going to represent the slope by the letter M1. Now to find out the slope, we're going to use the definition because all we need is the coordinates of 2 points that lies on the line. So here we'll start with the y coordinate of the vertex, so that's 2. From here we're going to subtract the y coordinate of the focus, so that's -6, divided by, since we started with the vertex, so we'll consider now in the denominator the x coordinate of the vertex, so that's -2, and from here we're going to subtract the x coordinate of the focus, which is -2. So solving this, we're going to get 2 negative of -6 will be +6, so that means we have 2 plus 6, that's 8 in the numerator, and in the denominator we have -2 added to +6, so that's 4, which means that the slope of the axis of symmetry line comes out to be 2. Now we want to find out the coordinates of point A, so we'll suppose that let the coordinates of point A be A, B. Now clearly V is going to be the midpoint of the line joining point A and point F. Now using the midpoint formula, we can say that if we consider the x coordinate of point A and add it to the x coordinate of the focus divided by 2, that's going to give us the x coordinate of the vertex. And to find out the y coordinate, we'll take the sum of the y coordinates of point A and point F. So we have b -6 divided by 2, and this will be exactly equals to the coordinates of the vertex. So that's -2, 2. Now what we can do, we can equate the x coordinates as well as the y coordinate. So a -6 over 2, that becomes equals to -2, which implies a -6 will be equals to -4. That gives us the value of a, so a comes out to b, so 6 minus 4 will be equals to 2. Then we can equate b -6 over 2 with +2, so that's going to give us the value of b equals to +10. So that means the coordinates of point A is going to be 2, 10. So this implies that coordinates of point A value is 2 and the b value is 10. So now we have the coordinates of point A. So here, what we'll do, we'll draw a line which is going to pass through point A, and it's going to be perpendicular to the axis of symmetry line. So here we have the directrix line that passes through the point A. And now our next goal will be to determine the equation of the directrix line. To find out the equation of the directrix line, what we'll be doing here is using the point slope form of a line. The point slope form states that if we have a straight line which passes through a point having the coordinate x1, y1, and the slope of the line is given, then the equation of the line will be given by y minus y1 equals to the slope m times x minus x1. Now we already have the point through which the line passes, that's 2, 10. Our next goal will be to find out the slope of the directrix line. Now, how do we find out the slope of the directrix line? Since we have the slope of the axis of symmetry line, we can use the property that the product of the two lines are going to be equals to -1. So that's the standard property of straight lines. So we'll consider the slope of the directrix to be m2. Now by definition of straight lines, we know that the product of m1, where m1 is the slope of the line of the symmetry line, and m2, the product that's always equals to -1. So that means m2 will be equals to -1 over m1. And we have already obtained the value of m1. So m1 came out to be 2. So that means the slope of the directrix will be equals to -1/2. Now we are ready to find out the equation of the directrix line. So we'll use the point slope form of a line. Here we have y minus y1. y1 is going to be the y coordinate of point A, so that's 10. This will be equals to -1/2, which is the slope of the directrix line, multiplied to x minus x1. So x1 is going to be the x coordinate of the point A. Now let's solve this. So we're going to multiply throughout with 2. So we get 2y minus 20 equals to, we have on the right hand side -1 multiplied to x minus 2. So we get -x added to +2, which will give us the equation x plus 2y minus 22 equals to 0, and this is going to be the equation of the directrix line. So now we have the equation of the directrix line, we have the coordinates of the focus, we can easily find out the equation of the parabola. So let us begin. Now, in order to find out the equation of the parabola, what we can do, we can use a point P on the plane, and P is going to have the coordinates h, k. Here P is going to represent the locus of the parabola, and the point P is chosen in such a way such that if we join point P and point F and drop a perpendicular from P on the directrix line such that it meets the directrix line at M, then PF will be equals to PM. That's the definition of a parabola. So here we have, from the definition of a parabola, PF will be equals to PM. Now, we can easily find out the length of PF because we have the coordinates of the endpoint. Here we use the distance formula. We'll take the square root. Underneath the square root, we'll take the difference of the x coordinate. So we'll take the x coordinate of P and x coordinate of F. Take the difference. So that gives us h minus -6. So we get h plus 6. We're going to square this value. Then add it to the difference of the y coordinates. So that's k minus -6. So we get k plus 6. We're going to square this value. So this is going to be the length PF. And now we need to find out the perpendicular length PM. Now there's a standard formula. So here, to find out the perpendicular distance, we have to take the absolute value. Now inside the absolute value, we'll have to take a ratio. In the numerator, we'll start with the coefficient of x of the directrix line. So the coefficient of x is 1. The 1 will get multiplied with the x coordinate of point P. So we have 1 multiplied to h. Added to, next we take the coefficient of y of the straight line, with that is 2. 2 will get multiplied to the y coordinate of point P, so that's k. And then we have the constant term, so that's -22. This will be divided by the square root of, we take the sum of the squares of the coefficient of x and y, so that's 1 and 2. So we have to take the sum of the squares to get 1 squared plus 2 squared. Now we're going to solve this. To solve this, what we'll do, we'll take the square on both sides, which will give us h plus 6 whole squared added to k plus 6 whole squared. That will be equals to h plus 2k minus 22. We're going to square this. Divided by, so square root of 1 squared plus 2 squared, that's square root of 5, but squaring it gives us +5. Okay, now we're going to expand h plus 6 whole squared to get h squared plus 12h plus 36. This will be added to the expansion of k plus 6 whole squared to get k squared plus 12k plus 36. This will be equals to, so here we have 5, so we can cross multiply the 5 with the expression on the left hand side. And on the right hand side, we have to expand h plus 2k minus 22 squared. We can use the formula for a plus b plus c whole squared. That should give us h squared plus 4k squared plus 22 squared, that will be 484. Then we have positive 4 times hk. Then we have negative 88 times k, and we have negative 44 times h. Now what we'll do, we'll combine all the like terms. So here we have 5h squared. Now we are going to subtract h squared to get 4h squared. Then we have 5k squared. So from there we are going to subtract positive 4k squared to get positive k squared. So h squared, k squared, h squared and k squared has been taken care of. Now we take 12 times 5, so that's 60. We have 60h, and from here we're going to subtract negative 44h. So 60h plus 44, that's going to be positive 104h. Then we have 12k multiplied to 5, so that's also 60k. So we have 60k, and we are going to add it to positive 88k. So that's going to give us 148k. Then we are going to transpose negative 4hk to the left hand side, and then we have to take care of the constant term. The constant term is going to be minus 124 equals to 0. Now finally what we'll do, we're going to replace the value of h with x and the value of k with y, which is going to give us the required equation of the parabola. So we're going to get 4x squared plus y squared plus 104x plus 148y minus 4xy minus 124 equals to 0. This is the required equation of the parabola, or the conditions that the coordinates of the vertex will be at -2, 2 and the focus at -6, 6.